Hello everybody, welcome back to the video series for our Chemistry 3A class. I just want to give you a quick tour of worksheet 5A. So the first thing to note is that if you go to the back page is essentially the same as your green sheet, and that has some information about naming polyatomic ions on it. So we're going to set that aside over here, and we'll get back to that occasionally as we need it. Alright, so then the next up is, as we said in class, this is a very painstakingly detailed worksheet teaching you how to name each different compound in chemistry. So we're going to go ahead and work through one example of each one and buzz through it real quick to show you how you would do each step. So first off, if you read down this first page, it's just going to start out by talking about the different types of compounds that we're going to name in chemistry. And those are molecular compounds, ionic compounds, and then acids. So we have to be able to identify the differences between those. So we've talked about that in class. I'll go ahead and jump right into some naming. So the first ones are done for you. This one's an ionic compound because it starts with a metal. It's a metal combined with a nonmetal. And it's specifically a type 1 ionic because sodium comes from the main groups of the periodic table, compared to type 2 ionic, which we can see down here. So this is a metal combined with a nonmetal, but it's type 2 ionic because copper comes from the transition metals. That's that inset portion, the lower portion of the metals. Next we have a molecular compound, carbon dioxide, because it has a nonmetal combined with another nonmetal. And then we have an acid, specifically an oxyacid, because it's hydrogen. So anything that starts with hydrogen is an acid. And it's combined with a polyatomic ion sulfate, so that's combined with an oxyanion. Hydrogen combined with an oxyanion makes it an acid, oxyacid. So we could keep going down here, and here we have silver oxide. So silver is a metal, so that definitely makes it an ionic compound to begin with. Now we have to just decide which type it is, an ionic type 1 or type 2. So the distinction again, type 1 is the main group elements, the ones that always have the same charge, and type 2 are the ones that vary in charge. So silver, if you remember, is in that special area of the periodic table where you have aluminum that's always a 3+, and then zinc, which is always a 2 positive, and then silver is always a 1 positive. So it is a type 1 ion. Then next, you have a tricky compound, ammonium oxide, and this cation, NH4+, is one of the exceptions where it's a polyatomic cation that replaces a metal in an ionic compound. So this again is an ionic compound, specifically type 1, because ammonium is always that same ion, so its charge can't be something different at a different time. Alright, we'll go ahead and jump to the next section, but if you have a question about the definitions, remember those are all written down right above this section. Molecular compound here is defined, ionic compound is defined. Then type 1 and type 2 are differentiated. Then acids and the difference between binary and oxyacids are differentiated right there. So then we'll jump ahead to the next page. Now we're talking about how to name those different ions you might encounter, whether it's type 1 monatomic single atom cations, type 2 monatomic cations, monatomic anions, polyatomic ions, or anions with hydrogen attached. So all of that is sort of outlined here directly. So first we have bismuth 3 ion. So the fact that it has a charge written in parentheses right here tells you that it must be a type 2, because those are the ones that we write the charge in parentheses. And again, that's all explained right up here where it talks about type 2 cations. So that's a type 2 cation, and all we have to do is write down bismuth with a 3 positive charge. That's the ion that it's talking about. Telluride, the IDE ending, is the ending that we give any element that's when it comes directly from the periodic table. So when it's an anion, this tells you that it's an anion listed on the periodic table. So you'd go to your periodic table, you'd find tellurium, you'd see that tellurium is in the 2 negative column. Same as oxygen. So here's your periodic table, and you can see that tellurium is in the column right here. And if you trace up, that's column 16. Everything in column 16 has a 2 negative charge. All right, then you would go down. Next is permanganate. Now, that is not a specific ion in the oxyanions of the nonmetals that you've memorized, so there's no permanganate here. So you're going to have to go down here and start hunting for it among less common names. And here we find permanganate is that ion. So there's really no way you would have known that except that you looked it up or memorized it. So we looked it up. It's MnO4 with the negative charge. So just keep doing that as you go, and either look it up on the chart, the periodic table if it ends in IDE for a monatomic ion, or look it up on the green sheet if it's a polyatomic ion. And remember, if you're looking for the IDE ending, that's the monatomic anions usually, and the polyatomic ions usually end in ATE or ITE. All right, next page. The next page here is the reverse of that, where you're just naming some polyatomic or some ions of different kinds. So on the previous page we were reading a name and writing the ion. Now we're looking at the ion and writing a name. So here's the potassium cation. So it's here, it comes from the main groups. So it's in column 1, so that's a 1 positive charge, and it's always a 1 positive charge, so we just call that the potassium ion. Here we have oxygen with a 2 negative charge. Anions, we end in IDE, so that's oxide. This next one up is an interesting one. It looks a lot like sulfate, right? Sulfate is right here, SO4 with a 2 negative charge. So sulfate is like this. But that's just like you stuck a hydrogen ion onto a sulfate. And so that's how we name it. Hydrogen sulfate. And that naming scheme is explained right here. So right on that previous page, we've explained that sort of naming scheme, as well as on the green sheet, right here. All right, the next one up is actually going on to how to write formulas for ionic compounds. So we've given you a little bit of an explanation with aluminum 3+ here. It's hard to see on the video, but that's a positive charge. So is that. And these are 2 negative charges. So you get 3 positive is 6 positive, 2 negative, 2 negative, 2 negative is 6 negative. So you've made the new neutral compound Al2 for 2 aluminums, SO4, 3 for 3 sulfates. So then we're going to do this on this gigantic chart here where we get in the habit of doing this over and over and over and over again. So my recommendation is to go ahead and look up each one of these ions one at a time first. So look up carbonate on the green sheet, CO3 with a 2 negative charge. Then look up acetate, then phosphite, etc. And then over here look up lithium, magnesium, ammonium. Titanium 4 is the 4 positive version of titanium. And then all you need to do is put them together in a way that makes a neutral compound. So for example, lithium with carbonate, I'm going to do some work right up here. We have a lithium with a positive 1 charge and a carbonate with a 2 negative charge. So the charges have to add up to 0, have to make a neutral compound. So we need 2 lithium pluses to make 2 positive to go with the 2 negative, and we're going to get Li2 for the 2 lithiums, CO3. like that. When we combine magnesium with carbonate, this next one down, magnesium is a 2 positive ion. 2 positive ion. Carbonate is already a 2 negative ion. So those are already perfectly balanced. So 2 positive goes with 2 negative. We get MgCO3. Last, let's do this one right here. We'll do the work for that up here. Magnesium 2 plus from here is combining with the acetate ion, C2H3O2 negative. So 2 positive, we're going to need 2 negatives to balance that out. So C2H3O2 negative. So 2 positives to go with 2 negatives. We're ready to write that in a formula. We write Mg C2H3O2 2.